In this video we are going to see about the multi-thread. So I'll give a live demo about the multi-thread. What is multi-thread? For that I am taking the VLC application. So this is my VLC media player. Now I am going to add some songs. And as you see that the song is playing, we can say that this is a flow of execution, a separate flow of execution to play a song. Now, while the song is playing, here I am changing the view, then I am getting the playlist, and here in the playlist I am going to add another song. This adding song to the playlist, this is another operation and another separate flow of execution. And again you can see that the song is playing without any interruption. So right now in my application two threads are running. The first thread is, we can say that, playing, and the second thread, that is adding songs to the playlist. Got it? Now I am passing it. So before going to start how to create multi-threads, I will show the explanation for multi-thread. It's very easy to follow. A thread is an independent path of execution within a program. Actually, there are two types of multi-process. One is called there are two types of multitask. Sorry, one is called multi-process and another one is called multi-thread. So what we have seen is multi-thread. Now in my system, the browser is open. This is one process, and NetBeans is running another process. Two. So many processes are running. It is an example for multi-process. But in the case of VLC player, it is not like that. In one application itself, multiple jobs, where each job you can call it as a thread. So you can see that a thread is an independent path of execution within a program, and many threads can run concurrently within a program. Within the VLC, many threads. One is playing thread and another one is adding song and removing song, and even I can change the visualization. There is an option to change the visualization. I'm not getting what is that option for, but so many different operations we can do when that application is running, where each task or each flow is a different one. We call each and every separate flow is a thread. So multi-thread application. Got it? Yeah. So now I'm closing it. Now whenever a Java program run, immediately a thread will be created that is called main thread, that starts from the main method. So how will you get the control over the main thread? So for that we have a standard method called currentthread. The moment we call this method returns the reference of the current running thread. Like this we have to call, because current thread is a static member in the class called thread. So the moment you call current thread, it gives reference, I'll say that it returns the reference of the current running thread. For any thread we can apply, not only for the main thread, for the other threads we can call it as child thread. For example, when I start the VLC player, the main thread is started, that is our application. From the main thread, playing one child thread, adding song, another child thread, like that. So like that, to get the reference of any currently running thread, we can call the method thread.currentthread. So what does it return? It returns a reference. That's why I told you, it returns something, right? And that something we can store it in a variable called t, and that reference type should be thread. Okay. Now I am going to display the t. We will see what does it display. Now when I run this, you can see that this is the output. This is a standard output. Thread. Then the first argument says what is the name of the current running thread. Then the second argument, that is called the default priority of a thread, and the priority ranges from 1 to 10. 1 is the least priority and 10 is the maximum priority value. And the third argument says that particular thread belongs to which thread group. It will say that is also in the main group. So the first argument says what is the name of the current running thread. The second argument says the default priority. For every thread, the default priority is 5, and we can change the priority of the thread. And later I'll explain about what about the priority. And the third argument says that to which group it belongs to. Again, we can say that it belongs to the main thread. Later, when we create multiple thread, you can see that this part alone, the name will change. And now suppose you want to change the name of the thread like this. Change the name of the thread. For that we have a setter method. For that, use thread object dot set name. Got it? For example, we are going to say that the name I want to give it as my thread. Some name you can give. Got it? And again, I am going to display what is the status of the thread. And see that you can see after name change, it's changed. And like now we are going to change the priority of the thread. So what about the priority? See, even though I told you that multiple threads are running in parallel, exactly it is not like that. At a time, only one thread can be inside the processor. So what? Now see that the song is playing, right? While now the song is playing, at that time I am going to add some new song like this. I am just dragging and dropping some new song. At the time, what happens? The playing thread should come out of the processor, or only then the adding thread can go inside the processor, then this addition happens. But this switching over, it is called the context switching. This switching over happens within a fraction of a second, so you cannot feel any delay here. You feel that both threads are running in parallel, but exactly it is not. Really, if you want to see one thread is waiting outside, add some 100 or 200 songs in a single stretch to the playlist. You can see that at that time, that adding thread takes more time in the processor. Are you getting? You can give some response, no problem. Fine? So, actually, at a time, only one thread can be inside the processor. So, all other threads who want to come inside the processor, they have to wait. Now, when we say that, now do the addition. So that thread will get higher priority than this running thread. Only then it can leave and the adding thread can come inside. Got it? Yeah.
So regarding the priority.
Yeah. What about the priority? Suppose we have 5 threads. Now let me call it as T1, T2, T3, T4 and T5. Assume that T1 is inside, whose priority is 5, and there is some thread. Let me call it as T2. It has a role wise. It may have somewhat we can say that more sensitive work than T1. For example, addition. See, its playing is happening. Now I want to add the song. So let me call the adding thread as T2. The playing thread as T1. So when I want to add, I want the addition to happen. So adding thread's priority will be higher than that playing thread priority.
So why is it like that?
Otherwise, the adding thread cannot go inside because of the playing thread is still running in the processor. At a time, only one thread can be inside the processor. So only when T1 leaves, the playing thread leaves the processor room, the adding thread can go inside. So the adding thread forces the T1 thread, the playing thread, to exit. So what happens? The playing thread will be waiting outside. Once the adding thread's job is over, it will just come out, so that the waiting was that playing thread was waiting outside will get a chance to go inside and playing continues.
But it's not visible, right? I mean, the playing is normal only. There's no delay.
Playing, yeah, that's why I told you that this switching over. That is, see, initially playing thread was inside the processor, so that was its running environment. So when it comes outside, its running environment is getting changed. So this switching over happens within a fraction of a second. See, I am taking the playlist, at that time I am dragging and dropping. So when the song is dropped into the playlist, addition is happening. So what happens? The adding thread goes inside the processor. So once its job is done, the adding thread should come out, so that the playing thread can go inside. It happens within a fraction of a second. You try to add some 100 or 500 songs at a stretch, then you can see that adding thread takes more time. See, drag and dropping means taking the song and putting into the playlist. So 500 times it has to do, isn't it? So it may take some 2 seconds or 3 seconds. Then you can feel the delay. You may think that your software is getting stuck. It is not getting stuck. It takes more time to process that adding thread. Till then, the plain thread has to wait outside. You might have noticed. Yeah, that is the acceptance. Understood? Good. Now I am going to change the priority of the thread. Change the priority of the thread. For that, T dot. Yeah, you may ask.
So in the output, this is how we got it, right? The thread name. Then the first one was the current thread, the priority, and the group. What is the group name?
Yeah. See, as you know that, see, let me take again this one. The moment I start the VLC, the main thread is started. And from the main thread only, that is main thread means your application. From the main thread only, I am playing a song, one child thread. Adding a song, another child thread. These two threads belong to the main group called, we can say, application. So from the main thread only, we are generating the other threads, we call it as children. So these two threads belong to the main thread. So it shows that here it belongs to the same group only, main group. When we create multiple thread, I will show you that here the child thread name will come.
So
And
the group indicates the method in which we
the group indicate, no, from the main method we can do some function calling and we can generate n number of threads here. From the main application, let's see. So that's what I told you, that the moment we run the Java application, a main thread will be generated. That is from the main method. The moment main method is invoked, a thread is generated. That is the main application. That is it. The moment I open the VLC application, the main thread is generated. It is not playing or adding song. That is your application main thread. When you play a song, a new child is born and now it is running in state. When you add, and another new thread is born and it is in the running state, like that. Got it? Yeah. Now? Yeah. So now I am going to give some priority. Priority should be integer value. For example, I will say that 7. The priority ranges from 1 to 10. And after that, we are going to display once again the thread instance. You can see that it is modified. So this is about only one thread. In the next video, we will discuss about multi-thread.